Hey everyone, welcome to my channel Chemistry. So ultimately I have came with a video, the one shot video. Actually, many one shot video I have planned to publish, and this is the first one shot video where I will just cover up that the chapters what we are having should not miss the part that we will cover up that portion today. So few points I have just picked, and each and every chapter we will go through, and in that one shot video the whole chemistry will be covered up. I think this video will support means will give you the mental support. I know you can answer, because this time this is not MCQ, the answering that question also will be better than before, I wish. And you can answer also, so don't lose your hope, so you can answer this time. So let's get started without wasting any time. Okay, so very first of all, which chapters we are having in semester 2 part? Chemical kinetics we are having, surface chemistry, D and F block element, coordination compounds, aldehyde, ketone, carboxylic acid, organic compound containing nitrogen, biomolecules, and chemistry in everyday life. So which chapters? Chapters are very important. Very important means you have to study all chapters. Questions are coming. And as the questions are coming from 35 marks only, so if you miss only any chapter, then many percentage of marks will go. So every chapter you have to complete, cover up. Still important, as my point of view, chemical kinetics is very important. Chemical kinetics very important. Coordination compound is also very important. And if you are covering up the organic part, so I guess the basic thing, if your organic basic thing is clear, you can answer. And the depending upon that organic part is also important part. And rest of the thing, like when we are having surface chemistry, if you have good concept, you can answer the question. DF block also few point, the variation of properties, that thing you have to know. So here also concept. And chemistry in daily life, the few points are there. If you can cover up these points, you can answer 2-3 marks very easily. So this is the scenario. Let's go point chapter wise. Let's start it. Okay, from chemical kinetics. So chemical kinetics. From chemical kinetics, very first thing, I will not go for the detailed concept. I will just go in one shot video. I will just touch up the points. So first of all, suppose we are having the reaction AABB to C cap C plus small d capital D. So here the small a, small b, small c and d are the coefficient, and A, B, C, D are the reactants and the product. So we can write the rate of the reaction equals to, for product case, 1 by A. For reactant side, we will write minus 1 by A. dA by dt is equal to minus 1 by B. dB by dt. And in case of, okay, so for product side, it will be plus 1 by small c dC by dt equals to 1 by small d dd by dt. This is the rate. And also we can write the rate in terms of rate constant, the reactant side to the power x, and the product reactant side b to the power y. Now x is the order of the reaction with respect to a, rate is the order of the reaction with respect to y. And this is not necessarily that all the time all the reactants will take in case of rate equation, but the thing is, if the reaction will be multi-step reaction, so for multi-step reaction, various step will be there. So the step will be the slowest. On the step, the order of the reaction depends on this curve, that reactants, and the number of reactants react to give the product is called the molecularity. So here, if order of the reaction is x with respect to A and order of the reaction is y with respect to B, then overall order of the reaction we can write as n equals to x plus y. And the other thing, as we are having a first order, zero order, second order reaction, but in the syllabus we are having only the first order reaction. So in case of first order reaction, the reaction kinetics, we can write the equation as rate constant equals to time needed 2.303 divided by time needed t. Time needed log A0 by A0 minus AT. So time needed how much? That means if A0 is the initial concentration of the reactant, then the remaining concentration of the reactant at time t will be A0 minus AT. So we can write the first order reaction as like this way, for first order rate constant. Next, what will be the unit of the rate constant? The unit of the rate constant K depends on the order of the reaction. That is, unit of the rate constant will be mole per liter per second divided by mole per liter to the power order of the reaction n. So that will be the unit. So from the unit also we can identify which order reaction is that. And then another thing is half-life of first order reaction is 0.693 divided by rate constant K. And another thing, how the rate constant is dependent upon the temperature, how it will vary. So this we can say from the Arrhenius equation. From the Arrhenius equation, so in Arrhenius equation, K is equal to A e to the power minus Ea by RT. In ln form, we can write ln K is equal to ln A minus Ea by RT. Log K is equals to log A minus Ea by 2.303 RT. So that is our equation. And beside of that, we are having some graphs also that you can find out from this equation. So if we plot A0 by A0 minus AT versus T plot, then how it will look like? It will look like, so if we plot log of A0 by A0 minus AT versus T, so it will be a straight line passing to the origin with the slope of K. So that will be the plot. So like this way, various plots we can get. We can draw the plot of reactant versus time also, because we know A is equal to A0 e to the power minus KT, and reactant concentration A versus time, if we are plotting, we can get, it will look like a straight line with the negative slope, and intercept will be log of A0, and the slope will be minus of K by 2.303. And the plots are also very important. For different order of the reaction, we can get different plot. So this is the overall thing of chemical kinetics. Next I will shift towards the next chapter, that is our, so in case of surface chemistry, the thing is on the basis of adsorption. If we go for the adsorption, means any substance we are having, above that some substance, another substance are getting adsorbed, and this is completely the surface phenomena. And the adsorption, the word adsorption can't be a bulk phenomena, it's always the surface phenomena. And here in the adsorption we are having adsorbent, and the adsorbent, the substance which invites the particle of some other substance to deposit on it is called adsorbents. Is on which the substance are getting adsorbed, that are called adsorbent. So this one will be the adsorbent, and the particles or the substance that will be adsorbed, they are called adsorbent. And in case of adsorption, the very basic thing is there, chemical absorption and physical absorption. Is physisorption and chemisorption are there. So in chemical absorption, chemisorption, the bonds are very permanent, that are not reversible. But physisorptions are reversible and bond are not permanent, they are loosely bound. So this is the main thing. And then from surface chemistry, what we are having, what we need to cover up. The thing there, we are having the one concept of colloids, dispersion state, dispersed medium. So dispersion we are having another thing. Another is coagulation. And in this thing, the related terms are the gold number, and we are having the lyophilic and lyophobic colloid. So if we go for lyophilic and lyophobic, from the term we can get, the thing is like lyophobic. The thing is like, whenever we are having a solvent, that solvent can be, the particles can be solvent loving, that will be lyophilic, and the particles can be solvent hating, that will be lyophobic. So as we know, as the particles are solvent loving, so lyophilic colloid. Colloid means in that some particles are there, in any solution or any that are another in another substance, so that another substance can act like the solvent. So as the particles are solvent loving, so it will be more stable than lyophobic. But there are some step, or there are some process how we can stabilize the lyophobic colloids also. So this is the basic thing, very basic thing, you have to cover up the things. Okay, that one was from surface chemistry. Next I am going for the DF block element. So in the DF block element, actually this is the part of periodic table, but still these are little different from the other atoms present in the periodic table. And the difference comes first of all from its that electronic configuration. If we go for d block elements, the d block elements are having electronic configuration ns2 n minus 1 n minus 1 d 1 to 10. And for F block element, the configuration is like n is 2, n minus 1 d 0 to 1, and n minus 2 f 1 to 14. So here the thing, here d orbitals incorporated, here f orbital. So because of their high difference in penetrating power, so f orbitals, that gives us high effective nuclear charge, because the screening effect is very low, very lower compared to other orbitals. That's why your high nuclear charge here is low, a very small size, so orbital contraction happen. And this special case is known as lanthanide contraction. Lanthanide contraction in case of lanthanides, and actinoid contraction in case of actinide. So this is the thing. And then when we are coming for d block element, we are having the various compound like scandium, titanium, vanadium, chromium, manganese, then iron, cobalt, then we are having nickel, then we are having copper, zinc. And if we go for their common oxidation state, that one plus 2, because all the d block element will donate its that ns2 electron first, then it will start to donate the d electron. And not always the electronic configuration will be maintained, because whenever there will be, suppose a configuration for neutral atom ns2 nd4, this is for chromium, but to stabilize the d orbital, how to make it half fill stable, it will be converted into ns1 nd5. So this, sometimes these exceptions may happen. If we go for the common oxidation state, that one is plus 2 after donation of 2 electron. There will be for scandium d1, d2, vanadium d3, chromium d4, manganese d5, 6, 7, 8, 9, 10. So this is the scenario. Then we are having, if we go for the size, change of size, if we are coming from left to right, the size will decreases up to around manganese or iron. Then after that the size will be more or less same, there will be not quite change of size. Now if we are coming for f block element, there is also various f block elements are there present, cerium, promethium, so various f block elements are present. So in case of A block elements also, the contraction of size will happen. And in the both of the cases, we are having the color thing and magnetic property. If there is any unpaired electron present, so it will give you color, the transition of the electron, as well as the paramagnetic property. So these things, colorness, the magnetic property is also important. If we go for the magnetic property calculation, for the normal case, magnetic property mu effective, how we will calculate? We will calculate this is this in terms of root over 4s into s plus 1, where s is the spin, s equals to number of unpaired electron divided by 2, n by 2, and it will become n into n plus 2 also. For whenever we are coming for d block elements, for this case the mu effective will be root over 4s into s plus 1 plus l into l plus 1, because here orbital contribution also comes. And if you are going for f block element, a little more further study, if you do it, you know, for f block element the mu effective not only will be ls coupling, that L and S orbital involvement, but also a new term J will be incorporated, and mu effective will be G into root over J, and where G value is equals to 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. Here a new term J incorporated. So this is the scenario for mu effective. So up to this you will remember the mu effective calculation. So how we can see, this will depend upon the number of electron, number of unpaired electron, and when L, that orbital coupling will be there, it will be root over 4s into S plus 1 plus L into L plus 1. This is the equation, this is the expression how we will express the mu effect. So this is actually the D block element. Next, coming for the coordination chemistry. From coordination chemistry, the basic, what are the things we are having? The nomenclature. Nomenclature means, suppose any name is given, and from the name you have to draw the structure or any structure is given. From this you have to write down the IUPAC nomenclature. This is the nomenclature thing. Once we got the nomenclature thing, then we are having the structure. In case of coordination chemistry, structure depends upon the coordination number, means how many ligands are there in the coordination sphere with the metal. So the number of ligand can be 4. Then the structure can be, there are two possibility of the structure. One is tetrahedral, another will be square planar. Then we are having the coordination number 6. If the coordination number will be 6, there is only one possibility, that one is octahedral. But the octahedral structure can be made by two hybridization, like that can be made by D2sp3, or that can be made by sp3d2 by hybridization. So D2sp3 will be inner orbital complex, inner sphere complex, and sp3d2 will be outer sphere complex. And next concept comes in terms of crystal field theory. And again, in coordination chemistry itself, very important, and crystal field theory is more important in part of coordination chemistry. Once we got the crystal field theory, what we know here, the D block element, 5D subcells are there, that will be divided into two parts. In case of octahedral field, it will be in the below, that will be in 3 or subshell, 3 orbital, above 2. Below one will be T2G, above one will be EG. If you are going for tetrahedral, the splitting will be just reverse. Above will go T2, below will come E. So this will be the thing, and naming will be also T2 and E. And if we go for the tetrahedral complex and square planar complex, if you go for the geometry, so optical isomer that we can get is, optical isomer we can get in case of square planar octahedral complex only, not for tetrahedral complexes. Then optical isomers come, and not only optical isomer, in isomerism we are having geometrical isomer and optical isomer, and this one is also very important. In geometrical isomer we can see actually cis and trans isomer there, and facial and meridional isomer is present there. And in case of optical isomer, we have to check the mirror image, whether the mirror image and the compound is superimposable or not. So this is the whole scenario of coordination compound. And there are many other important things also, that magnetic properties. So once we got the electronic distribution among the T2G, we can find out whether this is paramagnetic or diamagnetic, as well as whether it will form inner sphere complex or outer sphere complex, that means high spin low spin complex, depending upon a high spin low spin chart for the strong field to weak field ligand of the ligand series. That also we have to see. So there are very and many important things, so you need not to miss. And also there is a color chemistry for coordination compound. Okay, next going for the very important topic, that one is organic chemistry. Okay, let's start. So in organic chemistry, I am taking all the thing together. Like we are having first of all aldehyde, ketone, carboxylic acid. Now for that coordination chemistry, for organic chemistry, aldehyde, ketone, carboxylic acid, and organic compound containing nitrogen. So for those things I have made individual video, you can follow that. There also important things are mentioned. And one thing I will say, that be clear about the basic thing about organic, then you can go for the reaction mechanism also very easily. Basic thing means which are the nucleophiles, or nucleophilic site, and which one is the electrophilic site, and which one will be the leaving group, which one will be the electrophile, nucleophile, and which pathway to be followed, means the mechanism is whether it will be addition reaction, whether it will be substitution, elimination. Once you will get that, you can get the intermediate part also. So these are the things. And if you see their properties, their physical properties also depend upon the structure. If we go for the aldehyde having the CHO group, the ketone having the CO group, and the acid is having the CO2H group. So here are the tendency of hydrogen bonding, electrostatic interaction also, that usually that affects the boiling point and the solubility. Next, in the case of nitrogenous compound, we are having amine, we are having cyanide, we are having amine in the form of, means aromatic amine in alanine. And here what we are having the formation And here also aldehyde ketone carboxylic acid formation. The reagent for the reagent chemistry and what are important, the mechanism and nucleophilic electrophile, the whole thing you have to follow my individual videos for aldehyde ketone carboxylic acid and the organic compound containing nitrogen compound. Okay, so formation, if you are going for the formation, we can form a nitrogenous compound from alcohol, we can form them from nitro compound, we can form them from any haloalkane, etc. And then we are having the from amide we can form by Hofmann degradation. And we are having the thalamide synthesis, so from thalamide also we can form the amines. So there are various processes. Then the few of the important reactions are there: diazotization reaction, coupling reactions, and distinguish how we can distinguish the aldehydes, ketone, and how we can distinguish aromatic aldehyde ketone, how we can distinguish primary, secondary amine. So these are all are covered in my individual video. Please go for it. Then we are having the biomolecules part. For biomolecules, we are having actually the three parts. Three part means one is carbohydrate, another is proteins, and another is nucleic acid. Okay, in carbohydrate part again we are having the monosaccharide, we are having the disaccharide, we are having polysaccharide, and depending upon the functional group we are having aldohexose, we are having ketohexose, ketopentose. Depending upon the number of carbon we can say hexose, pentose, tetrose, etc. Then after that long chain, when it will form the cyclic chain, that time we can have the furanose as well as pyranose. And when it will make a that thing sucrose means suppose from monosaccharide we are getting disaccharide, so sucrose, like sucrose is formed by glucose and fructose, that time how they are getting attached, that part is important for structure. Then we have a protein. The building molecules of protein is amino acid, and we are having various amino acid, and that can be tested by Neen-Hydrin test is there to identify the amino acid. And in case of amino acid, one special amino acid is proline, which one is a cyclic amino acid, and where the nitrogen is present in this cycle, in this cycle, heterocycle. Then we are having nucleic acid. Nucleic acids can be of two types: nucleotide we are having, nucleoside we are having. What is the basic difference? In both of the cases, the nitrogen is base and the sugar part, ribose sugar part is present. But in case of nucleotide, phosphate group is present, whether in case of nucleoside, phosphate group is not present. And then we are having DNA, RNA structure. So these are the basic thing and what we have to study from biomolecules. And then came about the last chapter, and that one is chemistry in daily life. Chemistry in daily life or chemistry in everyday life. Everyday life. Actually, in everyday life, this is all about the disinfectant, the analgesics, or the tranquilizer, or the medicine we are using this thing. So let's go for this point wise. Okay. So first of all, we are having just few terms. We have to know that we have to take the basic idea. If any difference is there, if any knowledge means conceptual questions is there, and just the name of the particular thing. So according to syllabus, what you're having analgesic. What is the analgesic? The compounds which relieve all sort of pains without the loss of consciousness is called the analgesic or painkiller. Simply the analgesic we can call them painkillers. So that can relieve all kind of pain. So these are suppose aspirin, one of the painkiller. Then again, novel again, or novalgine is the painkiller, and few R's are there. Then coming for the tranquilizer. Tranquilizers are the substance used for treatment of mental disease. So tranquilizer actually controls the nerve. So we use tranquilizer in case of mental diseases, and this and higher center of central nervous system. And suppose if we want to go for any example of tranquilizer, we are having benzodiazepines, benzodiazepines. We are having diazepam, Valium, chlorodiazeperoxide means diazoperoxide, diazo salts are all tranquilizer, part of tranquilizer. Then coming for the antiseptics. Antiseptics, we are all aware of the term antiseptic. So what are the antiseptics actually? Antiseptics are the compound which kills or prevent the growth of microorganism or the germ, what we say antiseptic. So microorganism it can kill. So these are the antiseptic without making any kind of toxicity or harmfulness. So what are the few of the antiseptics example? The example of antiseptics are like bithionol, bithionol, terpenol, chloroxylenol, etc. Iodines are also, boric acid is also part, detols are also part. So all basically the all OH group contains antiseptic. Okay, then we're having disinfectants. So what is a disinfectant? The disinfectants are capable to destroy the microorganism that causes the disease. So these are the disinfectants that kills all the microorganisms that are not good for us, that can spread diseases. So disinfectant, if we go for the that example of disinfectant, so we can make the disinfectant by using phenol, by using chlorine, etc. Okay, then we are having another term, that one is antimicrobials. Antimicrobials are the drugs used to fight infectious disease. We are using this against infections. So few of the example of antimicrobials are sulfonylamide is one of the example. Then we are having sulfur diazine. This is also another example. Then we are having anti-fertility. From the term also you can get the thing anti-fertility. That will be against the fertility. That will be the anti-fertility, the most convenient and widely used method for birth control or the oral contraceptives. So here if we go for any fertility drug, we are having norethindrone, ethinyl estradiol. So we are having this. Suppose one of the example I am writing here. Norethindrone. Okay. Then we are having antibiotic. So antibiotics are the chemical bacteria that produced by bacteria, fungi, and molds and inhibit growth of the metabolism of the microorganism. And as we know, antibiotic, when we add antibiotic, suppose we are having any fever, so we need to kill the germ, we need to kill the that organism inside our body. That are the antibiotics we are using. And few of the antibiotics example are, what are the antibiotics? Common antibiotics we can write ampicillin. All of us know about ampicillin, penicillium, penicillin F, penicillin K, penicillin G, etc. Okay, then we are having antacid. About antacid, we are aware of the antacid. The term antacid means what we use that against acidity in our body, to neutralize the pH, to maintain the pH level, to neutralize the high acidity in our body, that one. So like many of the antacid contain sodium bicarbonate that may contain aluminium phosphate, magnesium trisilicate. One of the example of antacid is like omeprazole, lansoprazole, etc. Then we are having antihistamine. So what is the thing antihistamine? Antihistamines are, if any histamine produced because of allergy in our body, so that can be killed by antihistamine, like example Benadryl, Trimethoprim, etc. Then we are having antipyretes. Antipyretes are used to reduce fever. So a very common antipyretes is aspirin. You can take aspirin as one of the examples. Okay, next we are having the difference between antiseptic and disinfectant. Few of the differences that reduces or kills the growth of disinfectants on microorganism, but that kills the microorganism itself. So it kills the growth only, and it kills the microorganism in itself. And it does not harm the human tissue, does not harm the human tissue, where in case of disinfectant, that may or may not be toxic for our skin, for our body. So there are many other differences also, you have to follow the differences. Then there are some chemicals what we use in our daily life in our foods. So always, as we know, if we want to keep the food safe, food, if we want to preserve it, and if we want to use any detergent also in our daily life, that are also many chemicals. So in case of food preservatives are there, sweetener, not only the natural sweetener, artificial sweetener we are having because of any health issue. Now people use artificial sweeteners because of many advantages. So this is also important and present in the that specimen copy. Antioxidant also we use aspartame, saccharides, sucralose, a term is there, and allitame. So let's see what are the terms. So in case of food preservative, when we add food preservatives to keep the food fresh, we to maintain the food, we will use to preserve the food. We will use food preservative. So in among the many food preservatives, one of the important food preservative is sodium benzoate. Sodium benzoate is one of the ester and that we can use as food preservative. Then we are having the artificial sweetener. In part of artificial sweetener that we can prepare organic compound, artificial sweetener, and a few of the very important artificial sweeteners are saccharin and sodium salt of saccharin also, and sucralose is also one of the important artificial sweetener, aspartame also, and allitame also. So these are actually aspartame and allitame. These are actually the artificial sweeteners. So what we have to study, we have to know few of the points about this. Suppose saccharin we are having. Saccharin is 550 times more sweet than sugar. This is the thing. Primarily used as sweetening agent is diabetic patients. Because why we are using to control their intake capacity of calories. This sucralose, it made from sucrose. Sucralose we can get it from sucrose. And then we are having aspartame, one of the most successful and widely used sweetener is most successful and widely used sweetener is aspartame. Then we are having allitame, similar to, it's also similar to aspartame and more soluble, more stable than aspartame. So few of the points we have to know. Then we are having the last thing, that one is antioxidant. Oxidants are something that involves in oxidation, and that can be formed during that free radical produced in our body during aerobic cell respiration, that are the oxidant. And antioxidant is the compound which prevent that oxidation, the enzyme oxidation or any food oxidation, that are the antioxidants. So few of the examples of antioxidants are, first of all, butylated hydroxytoluene. So butylated hydroxytoluene. So hydroxytoluene, we all know the structure of hydroxytoluene. Toluene, we all know about the toluene. Then hydroxytoluene is there. Then butylated hydroxytoluene, one of the example. Butylated hydroxyanisole is another example of antioxidant. Butylated hydroxyanisole is also one of the example. As we are not having any structure, so I am not drawing any structure. We are not having the structure in the that syllabus. Saccharide, sucrose, allitame, these are all the part of artificial sweetener. So this is it in part of that one short video. Many one of you commented for this, and I have seen many of the comment about that your first semester not went well. So don't bother about that. Go for the semester 2. I hope the semester 2 will be better. Follow the point I have mentioned and the chapters what I have discussed, that follow these videos also, and go for that specimen copy very well and see which chapters are important. You can see by yourself also, and from my side what is my suggestion I have given. And here in this video also I have taken the points what you have to study from chemistry in everyday life, the last chapter, that is completely the quite biology based. You have to remember one or two time. If you study, you can remember easily. So study from the beginning. Don't study before night of the exam, so anything you can't get it. So try to study. If any help needed, do comment. And for this video, this much only. And thank you very much for watching. If one of your friends need help, share the videos with your friend, and don't forget to like if you like that video, and don't forget to comment also. So thank you.